So we'll start with what is scale and why we need it. What are the key steps in scale development? Followed by, once you've got through those steps, once you've got the data at hand, the next step is exploratory factor analysis, confirmatory factor analysis, followed by how do you assess the reliability and construct validity. So we'll be looking at so what is a scale and why do we need it? More or less, a majority of the research that is done is quantitative in nature. And primary research, when done in terms of, or when done quantitatively, you need something to measure your variables. Now that something is normally referred to as a scale, a questionnaire, or a measure. Most of the times, even 95% of the times or 99% of the times, there are already established scales that you can use. But sometimes a scale is not available. In our last webinar, we did discuss that how to develop a very basic scale for your use or for use in a particular study. Today, we are going to look at much more detail as to how to develop a proper scale in a scale development study. So a questionnaire, also called a test or a scale, is defined as a set of items designed to measure one or more underlying constructs, also called latent constructs. So these latent constructs are unobserved constructs, and you make them observed or you measure them through different items that may be combined into different dimensions. You're not measuring the construct by itself. You are actually measuring that construct through different underlying constructs or items that combine to make dimensions, and those dimensions represent that particular latent construct. In other words, it is a set of objective and standardized self-report questions whose responses are then summed up to yield a score. So what you do is, for example, you ask 4 or 5 questions pertinent to corporate social responsibility or servant leadership or internal marketing. Then you sum the scores of those 5 variables or 5 items or 5 questions, and that score actually represents the latent construct of social responsibility, servant leadership, or any other latent construct. Item score is defined as the number assigned to performance on the item, mainly through Likert scale. So how do you score that item? In order to score that item, you put a Likert scale in front of that item or that question. Scale development or construction is the act of assembling and or writing the most appropriate items. Now this is very important. Your items, your questions, something that defines your scale should be very appropriate, should be in line with the operational definition, should be in line with the objective that you have set for your construct, that what it needs to measure. So you get rid of all those questions that actually do not measure the underlying construct. How do you do this? If you have got your own understanding, okay, this question does not relate to this particular latent construct that I want to, or this particular scale that I'm developing, you get rid of it. And then you seek help from experts to establish whether a particular item belongs to this particular scale or not. The first and most important thing before going into the detail of scale development is operational definition. For instance, I'm interested in developing a scale for university social responsibility. Now, before going into how I should measure university social responsibility, or what items would help me measure university social responsibility, before going into that detail, I should be able to define what university social responsibility is. Before going into the detail of what items it should include, what literature should I study, you should define your university social responsibility. Now, how do you get to know about these concepts? How do you define, or how do you get these definitions? You search for existing literature. How to search? We've done a number of webinars on that. The videos are available on the YouTube channel, so you can have a look at them. So start by operational definition. And while you are looking at the definition, do not select a definition just because you have got it. Read some literature along with those definitions and see if it would fit your context, or see if it would fit your setting. So look for different definitions and see which one would fit your area, your setting, your context. Which one is understandable to you? You do not go for complex jargon because it is in a definition and it will look good. Do not do that. Look for something that is understandable. So the very first step, operational definition. Simply, how do you plan to operationalize? Use the construct in your study. If I am going for university social responsibility, I cannot go for any definition of social responsibility. I cannot go for definitions of business social responsibility. I cannot go for definitions of corporate social responsibility. I might not be able to go for definitions of sustainability. Sometimes sustainability is used interchangeably with corporate social responsibility. So look for definitions that fit your context. How do you define your constructs in this study? Obviously, more or less the same thing. Your measurement, your items, your constructs, your subdimensions, each and every step that you take after this will be guided by your operational definition. The items that you include, the way the items are grouped and dimensions are named or categories identified, it actually depends on the operational definition. Failure to have a clear operational definition, you are not developing a scale then. All your effort will be in vain. Now, we have already talked about this previously as well. So operationalization can go in the literature, and you can obviously, when you are developing a scale, it's better to define the concept in your literature while you are discussing that particular concept on which you are developing a scale. We'll be talking about how to write the literature of scale development paper, because it is totally or almost, well, it's quite different from normal paper where we are assessing relationships between variables. So once you've got the definition, put it in your literature. The next step, or what is scale development process? Now, there are different recommendations in literature on scale development process, or which scale development process one can use. There is one by De Villiers, Fur, Strenner, Price, and there are others as well. Again, let's start with what should be a scale or a proper scale development process. The first step, set object of measurement. What do you want to measure? How do you define that particular measure? These are the two most important things. And what do you want to achieve from that measurement? All these things are defined in object of measurement. I want to define social responsibility in universities. How do I define this concept of social responsibility in universities? Once I'm through this, the next step is generating the pool of items. Now, there might be a certain amount of confusion regarding this. How do you generate the pool of items? There are different ways to do it. The first and foremost is go into existing literature and see what scales are available on this particular concept. In general, if I'm looking into university social responsibility, the study setting is university, but the scale is on social responsibility. So you can go for and find out the scales that are on social responsibility. Once you find out, or once you get those scales, get yourself an Excel sheet. Put all those items that are in those scales in that Excel sheet and provide reference to each item or each scale that is available or from where you took it. Once you have done that, you have done this, the next step that normally one should do is go for the stakeholders, interview them, get them to discuss what university social responsibility is. This will give you an additional pool of items. Do not just rely on what the literature says or what is available in the literature. Get a bigger picture. For example, if I was to conduct, or I did study on university social responsibility or developed a scale for university social responsibility, I asked academics about what they think about social responsibility of the university. What is the social responsibility of the university? I asked the students about it as well. This gave me an additional pool of items that I utilized for my study. Do not just rely on the literature or what scales are available. The next step is set format for measurement. How do you think you are going to measure those items? What Likert scale are you going to use? How are they going to respond to your items or your statements? And what format will you use? Will you use a whole statement? Will they be in questionnaire format, or will they be in the format of a word that people can agree or disagree with? The next step, a very important step, go to the panel or expert panel to review your items. Now there could be other steps as well. So we are just talking about developers, and then we are going to move towards the other options as well, and then we are going to have a whole conclusive, a more comprehensive scale development process as well. So I'm just going to do some of these, explain what these terminologies mean. So once you have got this presentation, you know how to use it, how to study this. So how do you get this expert pool? These expert pools should be from the academics, plus from the field that you are studying. So in my case, when I was doing university social responsibility, my experts were actually academics, and they were the practitioners as well working in the university. So what I asked them about these statements. I asked them to read these statements. I asked them to assess each and every statement and tell me whether these actually help measure the underlying construct that I want to study. And before this, actually, there is one other step as well. It might come in, but let me discuss it now. I categorize the pool of items based on my own thinking, based on my own reading. So if there are, like, I generated a pool of 50, 60 items from the literature plus the interviews, I actually categorized them. And then I took that categorization along with those items to the experts. And I asked them, do you think that, okay, these items actually measure university social responsibility? And whether these items or the categorization actually stands? Would you like to change any item or its categorization? The next, consider inclusion of validation items. Now, validation items, there are different ways through which you include validation items. You ask one question at the top, you ask the same question or slightly different question that might negate the earlier question in the end. So if he or she is answering both them together or both of them in the similar manner while they should have been answered differently, this means that your respondent hasn't read the question. Validate your questionnaire. How to validate it? We'll be doing exploratory factor analysis and confirmatory factor analysis. Evaluate the items that do not fit the validation process, and then optimize your scale. See if it's like some of the items removed and the final scale is good in length, measures the underlying construct, fits the definition. Obviously, now you have completed the scale development process and you can move ahead. Now, for more or less all of them have got like similar things. So set the construct and the context. Obviously, what's the construct definition? Response format is same as set format for measurement. Assemble item pool, go for the literature, go for the expert, collect data, do the psychometric properties. Psychometric properties, reliability, validity, content validity, and everything. Standard actually identifies whether there is a gap for that particular scale that you want to develop. For example, if I go on and develop a scale for job satisfaction, I'm afraid I won't be able to publish it because there are maybe hundreds of scale already available. So I do not reinvent the wheel. I do not need to reinvent the wheel. The first step, this is a more integrative, a more inclusive scale development process, a more complete scale development process that actually starts with gap. So you do not go for any scale development. Scale development, although it's a complex process, although you are definitely adding something to the literature, but you do not just go on and collect data or develop a skill on anything. You have to identify whether there is a need to develop that particular skill or not. So if there are maybe 50, 60 scales developed on a particular concept, it will be very difficult to identify gap on that particular construct. So try to find out a particular area where there is a need for a particular scale. Like for example, recently I developed with Professor Merimon a scale on servant leadership. So we couldn't find a scale on servant leadership in higher education. So we developed one. I couldn't find a scale on social responsibility in higher education. So I developed one. So look for areas where you can't find a scale. Then theoretical foundation, the concept, how it belongs to the theory, how it's defined, its roots in the theory and everything. The purpose, more or less these things are already discussed. So you go on, then select the attributes. Sometimes what happens is, rather than going for a general scale for a particular concept, you identify attributes that you want to focus on. What do I mean by attributes? For instance, I'm interested in developing a scale for university social responsibility. So what happens is, I want to focus on just 3 or 4 aspects of social responsibility in university. I want to focus on social aspect, I want to focus on legal aspect, I want to focus on ethical aspect, I want to focus on philanthropic aspect, or maybe the community aspect. So now my whole scale development process will revolve around these attributes. All my questions, all my items will revolve around these attributes. You develop an overall planning and then you generate your item pool. Again, go to the expert, go to the literature. Set your test specifications. How do you plan to test your scale? What, and then administration procedures as well. How do you plan to, like, the question format? What would be the question format? How do you plan to use, or which Likert scale do you want to use? How are you going to develop, or how are you going to present your questionnaire? How do you plan to administer the questionnaire? Give it to the experts to review all these things, your specifications, your items, your administration procedure. Revise, there might be revision cycle, multiple revision cycle, maybe after pilot study again after pilot study you might have to do another pilot study as well. This might be the case. And finally you validate and then provide your, or write your paper. Now, having said all these, or having identified all these scale development process, I, in 2018, with Professor or Dr. Ayman Sajjad from New Zealand, we developed our own scale development process that I normally use, and it is published. So I'll be sharing that paper as well. We normally start with conceptualization or identifying the domain of the scale. The next step is item generation. Again, we go to the experts and the literature. We might conduct interviews or go for group discussion, focus group discussion to generate our items. The next step is item categorization into different dimensions. Categories. For example, once we've got 60, 40, 50 items, we categorize them. And then talk to the experts about that categorization. Validate that categorization through the experts. The content validity, the face validity. Then we go for initial data collection, pilot testing, and then conduct exploratory factor analysis to see whether the items that we have generated and whether the categorization that we have done actually stands or not. So once you have collected the data, you have to validate your own categorization. If it's validated, we go for reliability analysis, validity, and we propose our final items. And once the final items are proposed, we go for our main study and then do EFA again and see whether this EFA and the initial EFA with the factor analysis is similar. Sorry? Okay, now can you hear me? Can you hear me? Okay. Thank you. Might be lost due to some connectivity issues. Okay, really sorry. Today we are really sorry. We are having connectivity issues today. No worries. We'll start again. Okay. So let me share the screen again, and I know where I left. So let me start from there. Okay. So this is our own conceptualization, mine and Dr. Sajjad from Messi University. So it's more or less the same thing. You start with the identification of the definition, you generate the items both from the literature and from the interviews or group discussion. You take them to the experts, ask them to validate your categorization, ask them to tell you about whether the items that you have identified actually measure the underlying construct. You go for the pilot study. Once you've got the data for the pilot study, do EFA, check it for reliability and modify your scale. Once you have got the modified scale, go for the main study. And in there, you again do your EFA. Check whether this EFA and the earlier EFA from the pilot study are similar. And then go for the confirmatory effector analysis. Identify the reliability. Assess the validity. Assess discriminant validity, convergent validity. So more or less, these steps are similar to the earlier ones. Moving on. We start with actually factor analysis. So once you've generated the pool of items, let's say, how do you generate the pool of items and how do you store it? So let's say this is one study that we did on servant leadership. So what we did was, we actually first searched the literature on what scales are available. And once we identified the scales available, we read through those scales. And while we were reading, we identified, okay, these are the items that could relate to servant leadership in higher education. So we selected the items and we identified their dimensions from the literature to what dimension the earlier researchers actually identified. And we also identified their source, or wrote their source, the title of the paper or the authors of the paper. So these earlier pool of items, 97 items, came from the literature for our scale on servant leadership. I'll share that paper as well. So these 97 items. Apart from this, we identified some from the interviews as well. And then based on this, me and the professor, we actually identified or developed or shortlisted these 69 items. And we gave them to experts. Asked them if these are applicable to higher education or servant leadership in higher education. And if they are clear, or are they not clear? So they identified and they provided their comments. And once we had their comments, we actually modified the items. Again, the questionnaire was sent to the experts again to identify the, obviously your scale was like, our scale was at this moment 69 items. That is too big. So what we did, we asked them to rate or mark 6 items for each dimension that you think adequately represent the factors in context of higher education. So we went to the experts once, revised our items, we went back again. And then once they marked, we had 52 items. Even after this, we went back again and we finally tested our scale with maybe, if I remember correctly, 47 or 48 items, and finally we had 36 items. So keep track of what you are doing right from the initial list to the end for pilot study. So this is what we did for our pilot study. So this is how you store the existing skills. So once you have got the existing skills, once you have got the items for your pilot study, and now that you have distributed it through a questionnaire and you have asked the respondent to fill in the questionnaire, and now that you have got the data and you have entered the data into any software, maybe SPSS, maybe MATLAB, maybe Lizrel, maybe M+, or any other software, Jamovi that we are going to use today. The next step, the more very important step, is your factor analysis. So what is factor analysis? Factor analysis is used as a data reduction technique. How is it a data reduction technique? For example, now in this case you had 4750 items. Although you had categorized them into 6-7 dimensions, but you have to test statistically whether or not these items actually belong together or not. So what you could do is you go for exploratory factor analysis. Once you have got the data through pilot study, submit this data to any statistical software and run exploratory factor analysis and see whether these items that you have grouped together are actually grouped together based on the data or not. So what it does is it gives them, or it gives those 50-60 variables meaningful categories. And once you've got those factors, those categories, those components, you check them against your own conceptualization and delete the items if required. So what it does is it actually groups those 50-60 items into smaller number of categories, make them more meaningful. Factor analysis is a method for investigating whether a number of variables of interest are related to a small number of unobservable factors. These 50-60 items, can they be grouped together and identified as a dimension or as a latent variable? This is done by grouping variables based on intercorrelation. How are these items grouped? These items are grouped based on their correlation. We'll be looking at practical example of exploratory factor analysis. So a common usage of factor analysis is in developing objective instrument or scales. Factor analysis technique mainly examine the systematic interdependence among set of observed variables, and the researcher is mainly focused on determining the base of commonality among these variables. So what factor analysis does for you is it identifies the commonality. Which variables can be grouped together? Which variables can form a single category while others form different categories? Factor analysis has been extensively used in research for data reduction and summarization. Almost all these studies that you will see on scale development, they will have factor analysis. Almost all. Now, the ultimate objective is how well do the items go well together in case we are building a new scale. So you have heard about EFA, exploratory factor analysis, that is used for scale development, identify if certain items can be grouped together into different categories. You would have heard about the word CFA, confirmatory factor analysis. Now, when confirmatory factor analysis, or when applied to a research problem, these methods can be used to either confirm a priori established theory or identify data patterns and relationships. So both are used to identify, or exploratory factor analysis is used to identify whether the categorization that you have done actually stands or not. Whereas confirmatory factor analysis is used to test hypotheses. So specifically, they are confirmatory when testing the hypothesis of existing theories and concept, and exploratory when they search for latent patterns. I have done the categorization of 50 variables, but that is my categorization. How would I make it factual? Yes, this categorization actually stands. I have to get the data. And once I get the data, my categorization might be wrong. So EFA is used when you are exploring a pattern in your data and you do not know the prior pattern or have very little idea, or there is no established pattern in research. So in order to get that established, you go for EFA. Whereas CFA is more or less used to check the hypothesis plus whether your data fits your model or not. So you go for confirmatory factor analysis. When exploratory factor analysis is applied to the dataset, the method searches for relationship or interrelationship between variables. So those variables that have got good relationship are loaded together, come together. You might have seen that particular table in which certain items are grouped together. Then there is it's a ladder-like structure in scale development paper. So what it does is, how do you get that ladder-like structure? Through EFA. So basic terminologies in factor analysis. So when you are doing your factor analysis, you come across different terminologies. How do you define? How do you understand those terminologies? There's a separate video on exploratory factor analysis on the channel as well, so you can I did share it as well. So the first thing is Kaiser-Meyer-Olkin measure of sampling adequacy. Is your sample adequate for exploratory factor analysis? In order to do this, in order to judge this, you go for KMO measure of sampling adequacy. It's recommended that it should be over 0.5. Some say it's 0.6, some say 0.7. So try to go for 0.6 or 7. So whether the sample that you have collected is good enough for exploratory factor analysis or not. The Bartlett's test. Now this test is actually used to examine the hypothesis that the variables are uncorrelated in the population. In other words, the population correlation matrix is an identity matrix. Each variable correlates perfectly with itself but has no correlation with other variables. Now if this relationship or this test is insignificant, this means that you've got an identity matrix. This means that there is no correlation between variables. If there is no correlation between variables, how can you group them together? So a value less than 5 indicates that the data in hand do not produce an identity matrix. So what you need is a value less than 0.05. This means that there is a significant relationship between the variables that you have put in for exploratory factor analysis. Now if there is relationship, those can be grouped together. Just like in normal life we are grouped according to our relationships. Same is the case with your variables. They are grouped according to their relationships. So if you haven't got a significant result, or that's a problem. But if you get a significant result, you have passed this test and you're good to go for exploratory factor analysis. Commonalities. Commonality is the amount of variance a variable shares with all the other variables being considered. But in jamovi that we are going to use, it gives uniqueness. So 1 minus uniqueness is your commonality, or 1 minus commonality is your uniqueness. Normally it should not be less than 0.60, but even 0.50 is good enough. So percentage of variance, once you get the factors from your exploratory factor analysis, it gives the percentage of variance that can be attributed to each specific factor relative to the total variance of all the factors. So how much variance can be accounted by each factors that you have taken for this study? We'll be looking at that as well. Eigenvalue, how many factors can you extract, or how many factors you should extract? So for that, normally we go for eigenvalue, and eigenvalue over 1 is used. So all those factors that have got eigenvalue over 1 are selected for exploratory factor analysis. Don't be afraid, when you see the example, this all will be clear. Scree plot. Now this is another thing, it gives you a plot of eigenvalues, but it's sometimes very difficult to understand. So what we do is we normally go for eigenvalue. And it does the same thing, it identifies the optimal number of factors that should be remained in or retained in the final solution. Factor loadings, this is very important. Each item that you put in for factor analysis actually gets a loading. Technically it means that it's a factor variable correlation. So each your item belongs to a particular factor. So what's its correlation with that factor? It should be good enough. Normally it's recommended that it should be 0.7. That's a very absolute loading. But if even if it's 0.50 and other items have got higher loadings, you should retain it. Factor matrix, it's the matrix that contains all the loadings for all the items. Now there are different methods when you use exploratory factor analysis. The rotation methods. It helps you, or it makes the loading patterns easy to understand. There are different. We do not need to get into very technicality of these rotation methods. Let's do the basics, like Varimax. It's the most common one used. Almost all of my study used this. So you more or less go for Verimax. It minimizes the number of variables with extreme loadings on the factor. It minimizes the correlation between factors. Make it possible to identify a variable with a factor. Components are always orthogonal. Each component explains non-redundant information. So each component for itself. The correlation between factors is minimized so that each factor or each component has got its own individual identity. The opposite to this, okay, that comes later. The next is Quantimax. Quantimax actually minimize the number of factors needed to explain each variable. Tends to generate a general factor. It generates an overall general factor which we are not interested in. We are interested in identifying dimensions in a particular construct. So this won't work for us. The opposite to Verimax is direct oblimin. This is also used in research. Factors are allowed to be correlated. So you say that, okay, yes, these factors, the factor or the correlation between factors is not minimized. They are allowed to correlate. Promax, use this if you are not sure which one to use, but more or less in business research, Verimax is the most common. I would recommend go for Verimax. It's faster than direct oblimin and used for larger data sets. Simplimax is another generation for simple structure. Again, go for Verimax. Rotation that allows for correlation are called oblique rotation. So you will come across these terminologies while you are reading about exploratory factor analysis. So those rotations that allow for correlation between factors are oblique, while those that do not allow are orthogonal. Verimax obviously returns factors that are orthogonal. Oblimin allows factors to be correlated that are not orthogonal. EFA with CFA, I think we have already done it, so it's why it's repeating. Okay, now you would have seen this thing, measurement model. While you are writing about your scale development paper or while you are writing about your study, you would have come across this term measurement model. So the measurement model is the part of the model that examines the relationship between the latent variable and their measures. The latent variable, corporate social responsibility. The measures, its dimensions. In case of servant leadership, the dimensions were humility, authenticity, relationship building, pioneering. These were the dimensions. So how well these dimensions actually relate to the latent construct. And in the measurement model, we establish the reliability and validity of the construct. We establish the quality criteria of the constructs. So what is reliability and validity? Reliability is actually the consistency of your measurement or the consistency of the measurement instrument. The degree to which an instrument measures the same way in each time it is used under the same condition with the same subjects. So if you've got a scale and you give it to certain subjects under certain conditions, and you get the responses. So if you give that same scale to the same people under the same conditions, again you should get similar results. If you're not getting similar results, this means that there is a problem of reliability with your scale. So imagine that you are using a ruler to measure a book. The measurement won't change even if you use that ruler on the same book after 10,000 years. It won't change. This means that your measure scale is reliable. So let's move quickly to, so this means that it is consistent. For instance, let's say there is a watch, there is a wall clock, or there's an alarm clock. The clock reads 6:15. If nothing changes, if time stands still, will the clock still say the same thing? Yes, it's very reliable. You always know what exactly or what is going on. The problem is, even if the time doesn't stand still, the clock will not move. But is it reliable now? So that was reliability, consistency. What is validity then? Validity asks if an instrument measures what it is supposed to measure, how true or accurate the measurement is. So validity is all about accuracy, while reliability is all about consistency. These things might be reliable, but are they valid? They both report consistently, too consistent. A broken clock would always show maybe 6:15, or A weight machine, if I am standing on it, shows 165 pounds or say 100 kgs or 80 kgs. If my son stands on it, every time it shows 85 kg. But is it reliable? It is reliable because it's giving consistent result, but is it valid? So something might be reliable but not valid. So you can't even say that is reliable either. So but they are not measuring what they are supposed to measure. This clock is not showing the right time, and this weight machine is not showing the right weight. So the scale is not measuring weight, the clock is not measuring time, they are not valid. Every instrument can be evaluated on two dimensions, the reliability and validity, and it must be established. The reliability and validity both should be established, otherwise your scale or your paper will be, or more or less will be, rejected by the reviewer. So what is convergent and discriminant validity? Reliability, we use Cron-Batch alpha or composite reliability scores. For validity, we go for convergent and discriminant validity. So what is convergent validity? Convergent validity takes two measures that are supposed to be measuring the same construct and show they are related. So what convergent validity does is, it takes into account two or more measures, whether or not particular items come together to represent the underlying construct or not. A simpler definition. Whereas discriminant validity shows that the two measures that are not supposed to be related are actually in fact not related with each other. So how do you establish convergent validity and discriminant validity? For convergent validity, we use average variance extracted scores calculated based on loadings. I'll be sharing a calculator with you on how to do AV. For discriminant validity, we go for Forner and Larker criteria, and we use correlation and the AVE values to establish discriminant validity. Now, this was all the theory about scale development process, starting from defining the operational definition and coming right to the end, establishing the quality criteria. Now we will go for testing or finalizing the reliability and validity of the scale, the exploratory factor analysis. Before going into that detail, let me show some papers on scale development. Now this is the paper whose data we are going to use for testing. So this is the paper, the development and validation of stakeholder based scale for measuring university social responsibility. It was published in Social Indicators Research back in 2018. Yes. So I'll be sharing this paper with you. So in this scale, but okay, this is the introduction. Now, how do you write the introduction of a scale development paper? Since there are no relationship, you start with the need to develop the scale. You start with your general idea or the general idea from the literature as to what scales are available and what are the limitations of those scales and why there is a need to measure this particular scale in this particular context. Once this is done, you write the literature and you explain your scale like this: social responsibility of the university. So what is social responsibility of the university? What conceptual frameworks are available to explore or establish university social responsibility? What approaches have been used? How existing research has measured social responsibility? What are the limitations? What scales are available? And why there is a need for more scales? What are the limitations of these scales? All this in greater detail. Maybe in this case, there were many more pages because the reviewer asked for more detail. Then the procedures. So what I did was, or it was single right. I only wrote it. So I started with identification of the domain of the construct. Then the generation of items through existing literature and focus group discussion. The same thing that I've already identified. So what did I ask the focus group? I actually asked the focus group these questions. So the interview protocol is there. These were the questions asked. And once I asked those questions, I recorded the answers and identified the keywords from those answers. and using those keywords I designed or developed items, and then items from the literature and this group discussion were taken to the experts. So I'll be sharing all this paper. These dimensions were identified. These 1, 2, 3, 4, 5, 6, 7 dimensions, and I also got support from the literature that okay, different researchers have talked about these dimensions. These were the items. These are exploratory factor analysis results. These items defined here. What is the support for these items? From where did I get these items? So from the literature, some of them developed from the group discussion presented in a table. So you read through this paper and you will get to know how to report exploratory factor analysis, how to report or how to write the introduction and the literature, how to write the methodology, everything in greater detail. So this paper will be shared. So once I've got the data, I've put it in this software, and now my first step is exploratory factor analysis. Whether or not the dimensional structure that I proposed, for instance, I propose that these are the 7 dimensions that university social responsibility scale should have. And these 7 dimensions, in these 7 dimensions, each of these dimensions will have these items. Like this is my initial pool, their support and their categorization. Before EFA, this is my initial pool with all the items and their categorization. Now I need to do EFA to check or to assess whether this categorization actually holds true or not. So what I did was, at that time I used SPSS, but now I use Jamovi. So let's go and put it. So I've already got the data here in Jamovi. Anyone who's not familiar with Jamovi can go to the channel and see the videos on Jamovi. A very good software. I really like it. Very easy to use. So let's go to exploratory and we will use principal component analysis. Actually, exploratory analysis or exploratory factor analysis got 2 methods: principal component and principal access factoring. We normally go for principal component analysis because we want to extract the principal components that exist in a data set. So we go for principal component analysis, and here we see all the items that are part of my study. So let's put all these in here and see what we get. So let's start with these items. OPR, operational responsibility, it has got 8 items. Then the next was stakeholder responsibility, and this one had another 6 items. Then legal responsibilities, another 8 items. Ethical responsibilities, another 12 items. And RE actually stood for research and development responsibility. So research and development responsibility had how many items? 5 items. Then philanthropic responsibility had 7 items, and community has got 8 items. So all those items that belong to that scale, that you think that belong to the scale, should be put in together here in this list box. If you are using SPSS, again same thing, just put them together. Nothing would change. Now here are the options. Let's look at the options first. Bartlett test, which is one of the assumptions that you have to check. KMO, whether or not your sample is good enough. Eigenvalue, to identify how many factors should I extract. So we based it on greater than 1. We can have component correlations as well if you want. So Verimax, since the correlations are minimized, we do not use or we do not need these component correlations. We can have scree plot, initial eigenvalues, the component summaries, and we'll be using Verimax. So it's running. Let's wait till it gets or till it runs and identifies the factor structure for us. Okay, here is our factor structure. The loadings. Okay, now how much should be the loading? We normally keep it to 0.40. So let's keep it to 0.40. I think in this paper I kept it to 0.50. So let's start with 0.40 and then we'll have a look at it again. Yes, it was set to 0.50, so let's set it to 0.50 here as well. Okay, now have a look at this. Operational responsibility had 8 items and all these are loading together. Why are they loading together? Because all of them have got good correlation within themselves. Because these 8 items are actually representing one construct, one category that we identified. Same is the case for stakeholder responsibility, legal responsibility, ethical. But if you see, some of the items are actually not loading. There is no loading for some of the items, like legal responsibility, LG1, it hasn't got any loading. Ethical, ET1 or ET4, this one hasn't got a loading. This one is loading onto 2 variables actually. 4 is it's loading onto 1 and it's loading onto 7. So let's say what we do is, because this is not loading anywhere, there is no loading, it has got loading less than 0.5. So since we are going to or not going to use any items that has got low loading, so let's first remove LG1. So let's say LG1 removed, and let's see what happens to the structure or matrix. This is your matrix with all these values as your loadings. The end is uniqueness, so commonality is 1 minus uniqueness is your commonality. Now LG1 gone, all items now loading. ET1, there is no loading for ET1, so let's remove. Sometimes what happens, if you do not remove them all together, remove one by one, because sometimes with the removal of one item the other starts to load well. So remove ET1 and it's going to start again. It's a stepwise process, and primarily more or less it's an iterative process. So you keep on removing items sometimes, and sometimes what happens is, if you are putting all items together, so we'll be talking about some troubleshooting as well later. ET4, let's move it. So we'll be talking about how do you troubleshoot if you do not get a good factor structure. So how do you troubleshoot that situation? So we'll be talking about that as well. Now it's taking good shape, so all good. Let's go down a bit. Let's see this one, com1, com2, com3. Com4 is problematic, but let's leave it for now. Com6, there's no loading for com6, so let's remove com6. What happened? So okay, com6, and we remove com6. This is why I like jamovi, because if this was SPSS, you would have to go again and again into the menu items and do it again and again. Looks good, but these 2 items still not loading onto their construct. They should have loaded onto 7 with these community engagement items, but they are loading separately. This means that these 2 items may not well be related to these 5 items. They are not representing this community engagement. So what we do is, since we hypothesize that these 2 items belong to this category and they will load together just like others did, but this is not the case, so let's remove these 2 as well and see what happens. And 4, again it's cross loading, so we'll remove the 4 as well. Why it is cross loading? Because its loading is higher on factor 1 with ethical responsibilities, and it's loading with its own dimension on number 7 here. So this means that this item lacks clarity in your research, so remove it. Because you still have 4 items left, you should have at least 3 items in a particular construct or in a particular factor or dimension. In this case it's 4, so we will keep it. Now we see a more clear factor structure. You can arrange it in the Word document like this will be 1, this will be taken to 2, 3, 4, so it will become a ladder like structure. How much variance is extracted through each factor? Factor 1, the variance is 15.22, again so on and so forth. It's descending order. So Overall, it's 69%, which is good. Assumption checks out. Bartlett test significant. Overall, your measure of sampling adequacy is 0.938, way over zero point 0.6 or 5.5 recommendation. The eigenvalues, how many factors did you extract? 7. So if you look here, 7 factors have got eigenvalue greater than 1. So that's the reason we've got 7 factors. This is a scree plot. If you look at 7, it almost breaks down. That's the reason you see 7 factors here. So this is how you do your exploratory factor analysis. Now the big question. In this case, I was very lucky to have a very clear structure with removal of, let's say, 1, 2, 3, 4, 5, 6, 7 items. What if you get a factor structure right at the start that doesn't make any sense whatsoever? And you keep on moving items here and there, removing them, adding them, playing with it, and it does not give you any indication as to what is happening. How do you tackle that particular situation? How do you tackle a particular situation in exploratory factor analysis when you've got too many items loading everywhere on the factors and you do not know what to do with it? Here is something that I normally do. Let's remove all these. And this is how you can troubleshoot during exploratory factor analysis. Since you now have different dimensions in your scale, so what you do is you test each of the dimension separately. Let me test this first one too. Okay, now only this first one. All others not added yet because I'm getting problems in my principal component analysis. These items are not loading together. So what I do is I add these factors one by one. These items factor by factor. So now I've added items for operational responsibility. Now I see this factor is not problematic. No issue whatsoever. Remove it. Let's test the other one. Let's go for stakeholder responsibility and see if this has got any problem. No problem whatsoever. Remove. Go for the third one. Let's see this one. No problem whatsoever, and so on and so forth. So you keep on adding, because I was lucky with this scale, there was not much problem, but add each construct with its items separately. And if you see certain items loading together, like this was the case with in our case community, what happened was 2 items were loading separately and 1 item was cross loading. So what I did was I actually removed these 3 items. So what you can do is remove these 3 items, because this is a problematic scale for you. You will be left with 5 items. So remove these 3 items and then you may test the whole scale together. Once you have checked each of the individual factors with their items and removed the problematic items, then you can check the whole scale together and hopefully your problem will be solved. This is what I normally do. So now this is your exploratory factor analysis. Once you are done with exploratory factor analysis, the next step is confirmatory factor analysis. The confirmatory factor analysis assesses whether these items that belong to a particular factors actually fit the data or fit the structure or not, the structure that you proposed. So in order to do confirmatory factor analysis, let's first remove this. Okay, we are now clear. So in order to do confirmatory factor analysis in Jamovi, what we do is we go for factor, confirmatory factor analysis, and here are our items. So now it is asking for factors, because now we have done exploratory factor analysis and now we know what factors we have, how many factors we have. And let's go for okay. Now yes, we'll do it quickly now. So 1 2 3 4 5 6, and then LG1 was removed, so LG2, 8, and then ethical 2 3 4 was removed, so let's go for 5 6 7 8. Go for relationship, research, sorry. Go for philanthropic. Go for community. Okay, now it's loading and we've got these options here. SRMR. Let's go for path diagram as well. Let's go for modification indices as well, although you cannot do much with the modification indices in Jamovi. In Amos or any other software, you use modification indices to improve your model fit. So it might take some time because obviously there are a number of items here. Residual covariances, here it is. We are looking for standardized estimate. Here are our results. We've got the loadings, the standardized loading, how well each of these items is representing the underlying construct. The factor 1, which is OPR, the factor 2, which is SR, the factor 3, which is LG, so on and so forth. So how well these items are representing the underlying construct, we know this through our standardized estimate, that is our loading. Now these are 7 factors that we extracted from exploratory factor analysis, and if we see, all these loadings are quite good actually. So we do not need to remove any item during our CFA. All these items very good loadings over 0.7 for each one of them. No, few less, but still the others are over 0.7, so we do not need to remove these items. These are the correlation estimates. Covariance unstandardized relationship value or statistic. Once it's standardized, it is the correlation. So how is the correlation of factor 1 with all the other factors? So you can develop a matrix based on this that we can use further to establish discriminant validity. So this you can use to build your own correlation matrix. Use Excel to develop or build your own correlation matrix, like for example 1 2 3 4 5 6 7. These are the 7 factors. 1 2 3 4 5 6 7. These are the 7 factors. Now what is the correlation between 1 and 1? Obviously that will be 1. You do not need to write it. What is the correlation between 1 and 2? So you put in your correlation matrix here. Just what you can do is just simply copy it from here, export it into that Excel form, and just copy it into those cells. Now what you can do is just like copy this text from here and put it in your Excel sheet here, and this is the correlation of factor 1 with all the other factors, factor 2 3 4. So just copy it from here and you can put it here. So this is how you keep on putting these things and build your own correlation matrix. This is factor 2 with all the others. And this is the third one, so just copy it because we are going to use it for discriminant validity. So let's use it and put it in here. And this one here. So this is now your correlation matrix, and if we see the correlations are good enough, not very high, not very low, so this is your correlation matrix done. So these are residual covariance. Let's leave it for now and let's go for model fit. Your chi-square, more or less, since the sample size is high, it would be significant, but what we are interested in is CFI, TLI, SRMR, RMSEA. In this case, RMSEA is 0.6 or 0.06 rather, which is less than 0.08, so we can say, well, yes, it is a good fit. SRMR is also less than 0.06, so good fit. But the problem lies with TLI and CFI. So in order to improve this, what you can do is you can use modification indices, and you see these reds, these are problematic. So in one particular scale or one particular construct, you could draw covariance between the two items that are red. For example, SR2, SR3. We can draw covariance between SR2 and SR3. If I remember correctly, I did some. There are different opinions on this. James Gaskin says that you can do this and correlate or covary these indicators together. I haven't reported the model, the diagram of the model, but I remember I did this. So, but the problem with jamovi is you cannot covary these items. For that, you either have to go for R language where you can do this, or you either go for Amos, Lizral, or other softwares. So, but stay tuned. We'll be starting R soon on how to do EFAs, CFAs, and statistical analysis in R soon, hopefully. So this is how you can further improve your factor or CFA results, like covary OPR1 and OPR2 on factor 7. So if your modification indices are too high, if they are too high, what you can do is you can most certainly delete the item, because this amounts to cross loading. There are cross loading issues in your study. So this is something that should be considered. Okay, so, and you cannot cross or you cannot co-vary items from one scale or one dimension to items of the other dimension. That is wrong. You can only use modification indices to co-vary items from a similar construct. You cannot co-vary one item, for example SR1 with OPR1. You can only co-vary SR2 with SR3. So this is standardized residual covariance. Some of them are very high. So if you go on and remove these items, your problem to a certain extent might be solved as well. Like this OPR5, the standardized residual covariance is 92, which is significantly high. So this is how you do CFA in Jamovi or any other software. So once you've got this data about model fits and everything, and once you have decided, okay, these are the items that I'm going to keep, the next step is to establish the reliability and validity. So how do you establish reliability and validity? What I have done is, or what simply you can do is, for composite reliability, you can use a composite reliability calculator. For alpha value, you can use SPSS. There is a video on the channel. You can watch it and do the alpha. But today we are going to focus on composite reliability, because that is normally reported in scale development studies. So for that, I've created this calculator. There is one available on the internet, but I was having trouble with that, so I developed one my own. Very simple calculation, very simple formula. So what you do is you just put in loadings, it calculates the error variance, and using some formula, there is this formula, you can calculate your composite reliability. I'll share the calculator so you do not have to make your own. And it's loading, just hold on. So composite reliability, and then there is a calculator for AVE, average variance extracted, which is the measure of convergent validity. This shows that how well the items are coming together to measure the underlying construct. So I'll share this calculator as well with you. And it's loading, just hold on. Okay, here it is. So now we've got the loadings and everything. So let's calculate the composite reliability. This is just another measure of reliability that is used with CFA, because in CFA everything is related to or based on loading. So it uses these loadings to calculate composite reliability. So what you can do is, once you've got it, just paste it here. Let's do for OPR. Copy and just paste it here. And the composite reliability for OPR is 0.934. So what you can do is just keep a note, like even in this table, so you can say that the CR value is 0.934. And similarly for other indicators, Let's do for stakeholder responsibility. Just copy it, paste it here. So 0.928. Same, so on and so forth you can do for all the latent variables in your model. Calculate composite reliability and then report it in your research paper. Now, how do you calculate average variance extracted? In order to calculate average variance extracted, what you do is you go to average variance extracted calculator. Similarly, just paste this here, and similarly what you can do is copy these loadings, use the standardized estimate please, only standardized estimate, otherwise the values will be wrong. So just copy them here from here, put them here, and now the AVE for operational responsibility is 0.66. so just what you do is OPR 0.66. its square root, we will use it for discriminant validity, so this will be also be part of the calculator. Similarly you can do for SR, it's 0.63, and similarly for LG, let's do it for all of them because we are going to need it for our discriminant validity. 0.58, 0.58, factor 4 is 0.61, 0.61, and factor 5 this is your factor 5, then your factor 6, this is it, 0.56, 0.56, and then your factor 7, the last one with 4 items. Just remove the previous ones so that there is no mistake in doing. And then 0.65. once you've got this, just take the square root. So now this is how you have established your composite reliability and convergent validity. All these values of AVE are greater than 0.05. So once they are greater than 0.05, you know that convergent validity is established. Now how do we establish discriminant validity? What we do is we just copy these two columns here and we get to our table here, paste it here, and factor number 1 here, this in this empty cell, let me highlight it, let me, now it must be clear. Now we are establishing discriminant validity. Now here this empty cell where we do not report 1 or wrote 1 because the correlation of 1 with 1 would be 1. What you write is you write the square root of AVE. Square root of AVE for factor 1, 0.8124. Square root of AVE for factor 2, 0.793. Square root of AVE for factor 3, 0.761. For factor 4, 0.781. For factor 5, 0.748. And the 1, 2, 3, 4, 5 is 0.7681. Factor 6, 0.7483, and the last is 0.806. Now how would I know that discriminant validity is established? I've just put in the square root of AVE. How do I establish according to Forner and Larker criterion that discriminant validity is established? So once you have calculated the AVE values and you put them on top here, right above the correlation between constructs, what you do is you assess whether this square root of AVE is higher than all the correlations underneath. So the square root of AVE for factor 1 should be higher than its correlation with all other factors. In this case, yes, factor 1, the square root of AVE for factor 1 is higher than its correlation with all other factors. Same is the case for this. 7.793 is higher than all the values underneath. Same for factor 3, same for factor 4, same for factor 5, same for factor 6, and obviously there's no value underneath because all the correlations have already been established. So this is how you check for discriminant validity. Now you have made sure that your quality criteria is met. You have checked it for loadings, you have checked it for reliability, you have checked it for discriminant validity, convergent validity, and how do you report it? In the analysis section. So you can look at these papers, they'll be in the description as well. So this is how you report the dimension, the estimate, the loading estimate, the composite reliability, and the AVE in single table. For discriminant validity, just create another table. And how do you write about it? Just a paragraph or two on AVE was met, discriminant validity was checked because the square root of AVE for each of the construct was higher than its underlying correlation with other constructs. And if you've got model fit, just report the model fits as well. So this is how you establish the reliability and validity of the scale. I hope now things would have been or will be much clear regarding scale development.